Today I'd like to show a little bonus feature with the MDO3000. This instrument is billed as 6 instruments in one. You have the spectrum analyzer, scope, mixed signal, bus capability, DVM, counter. One thing that isn't mentioned, it's actually capable of doing a fairly reasonable TDR measurement. So we have a built-in arbitrary function generator of this preset, just outputting pulse waveform at the moment. Doesn't really matter what we set it to. We bring out the time base. The rise time of our AFG is relatively slow. We're on 4 nanoseconds per division there, so that's what, about roughly a 4 nanosecond rise time. But the aux out pulse from the scope can be set to be synchronous with the AFG. So let's have a look at that. It's under the utility menu, aux out, AFG, pop that on, so that's on. Our channel 1 is now on the aux out pulse, synchronous with the AFG output. Bring that up, time base out. You can see our rise time is much faster. That's on 1 nanosecond per division. I'm certainly sub 1 nanosecond rise time. I've got a 1 gigahertz scope, so it's only really capable of measuring, well, it isn't capable of accurately measuring that fast an edge. But we're certainly sub 1 nanosecond, which is fast enough for reasonable TDR results. So I have the output of the aux out coupled through T-piece, 50 ohm coax onto a 50 ohm load. If I remove the 50 ohm load, we can see the reflection as you would expect. If I short the end of it, okay, short to ground, our signal goes to ground. So here we've got our 50 ohm trace for the length of this cable. If I were to increase the length, you can stretch that out a bit. I'll join it with a T-piece just to show a little impedance bump. Put 50 ohm back on the end. Okay. So now we can see there's a small bump here just for that BNC T-piece, and then back to 50 ohm for the coax. And if I pop my finger in the T-piece, you can see I'm just about affecting that little impedance bump we're seeing. Okay, so we don't have fantastic resolution in terms of impedance, and we've got limited time resolution, but good enough to see a BNC T-piece, a feature of that sort of size. So that would be fine to check that PCB traces are the impedance you think they are, be it 50 ohm, 75 ohm. If you want to check very short traces or small features on traces, you would need something faster, be it a full featured TDR or a VNA. I pop in 75 ohm piece of coax instead of the 50 ohm. Remove that. So there we go, we can now see our 50 ohm stepping up to 75 ohm. So yeah, good enough to make a ballpark figure on relatively long traces. Okay, thanks guys.